Okay, students. Today's topic is backpropagation. Backpropagation is an algorithm which makes the learning possible in neural networks. It is a very important algorithm, very significant algorithm, and what happens in this algorithm is it adjusts the weights in the neural network in such a manner that as you go on training the model, you get better and better accuracy. First and foremost, what I would like you to know is that we are learning neural networks and uh, how neural networks learns. Learn means understand the patterns in the data such that neural networks can take their own um, predictions or classifications. You have a neural network, a feed forward neural network, where you have nodes and nodes are connected. What happens is initially input is given. This is input, this hidden layer, this is output. Input is given and it is feeded forward in a forward direction. It moves in the forward direction. And then here there are some weights. Weight. Every arc will have a weight, edge. Means this is connecting point between this node and this node. This is the first node in the first layer. This is the first node in the second layer. And these two are connected by this edge. And over every edge, there is a weight. And initially, these weights are initialized with random numbers. However, there are different approaches to initialize weights. By far, the most used one is random initialization. And then this is x1. So what happens here? X1 into W. Okay, that is feed forward. Here you get output. Output is y hat. If the actual output is 10 and predicted output is 8, then what is the difference? is 2. Difference is 2. Means what is the error rate? Error is 2. Why error is 2? Because our model is predicting 8, but it should predict 10. Essentially, 10 is the correct value. However, our model is predicting only the value 8, not the 10. So difference is 2, and that is known as the error rate. This error is propagated back. Why it is propagated back on all the paths? Because our goal is to minimize this error. It is 2. Next time it may be 1.5. Next time it may be 1. Next time it may be 0.5. And apparently, there is no model that 100% accurately predicts or classify the things. Every machine learning model will have some error. Well, our goal is to somehow take the error down and down until it cannot go further down. Okay, the 100% accuracy mostly is not achievable, and here we try to minimize the error by back propagating the error on all the paths such that these weights get adjusted or updated, and these weights next time will be different from the previous iteration, and perhaps you get an error which has been reduced. Okay, students, any doubt you can ask me. Oh, no one is there? Only Vinod is there. Okay, Vinod, if you get any doubt, you can ask me. You can interrupt and you can request. Right. So try to understand here the gist of back propagation. Back means you are going in this reverse direction, and propagation means everywhere on all the paths, propagating something, you know, on all the paths. This is your back propagation algorithm. What this algorithm does is takes the output, predicted output, back propagate means send back on all the previous layers, and gets these weights updated. This gets reached to this point, and again the process repeats. Input weights and hidden layer weights and output layer. This process repeats, gets the improvised output. Again, compare this with the actual output, and further back propagate that on all these lines, on all these edges until the input. Update the weights by following feed forward direction. Get the output, and this process repeats. Okay, this is known as When you complete for every data set all the iteration, then it is known as one epoch. One epoch will be completed in this manner. Actually back and forth. First start with the fourth, put forward all this, then send back, then forth, then back, then forth, like this. This process continues for as many samples um, as they are available in the data set. And for the um, specified batch size, this process continues. And when completely you cover all the samples, then it is known as one epoch. And this process is known as training. What happens after training? You get a model. What is a model? Model has these weights initialized, and to this model what do you provide? You provide testing data. And what do you obtain? You obtain the output in the form of a class or category or prediction, depending on the type. uh, you get a class, category, or prediction value. And you measure the accuracy. And when you measure the accuracy, you get to know how well model is performing. In simple words, students have been trained during the semester. How students have been trained? By conducting classes, okay, by imparting education and knowledge. Students are being trained. And after training, students acquire some knowledge. And when the question paper comes, this this knowledge is nothing but a model. And during exam, testing is done by giving the question paper. And what student does is write the answers. And based on the marks that he obtains, mm, it is decided whether the student has properly been trained and properly acquired the knowledge or not. All right. So marks, your marks is like model's accuracy. If you obtain 90%, then it means that 90% of the knowledge has been acquired by you from this training classes. If our model accuracy is 90%, 92%, we can say that model is performing better or good. So in this back propagation, okay, so look at here. This is the back propagation visualization. What is happening here? These are inputs, hidden layer, outputs, and every edge has weights. And the training process learns the weights. Look at here. W1 is 0.15. Perhaps these are the initial weights. Random values will be assigned as initial weights. All right. Uh, Look at here. This is our neural network, and these are the weight values. These two are bias. These are weight values. This is the output. This input, output, output. Two outputs. What happens? This training process takes place in two passes: forward pass and backward pass. In forward pass, uh, from input layer, the data travels through the hidden layer to the output layer. And in the backward pass, the output or error travels from the output nodes or output layer through the hidden layer to the input layer, and this process continues. And look at here. Here it shows the calculations. Please pay attention here. Try to understand. If you don't, please ask. Mm, Here, this net H1, what is net H1? It is calculating W1 into I1. W1 is the weight, I1 is the input, plus W2 into I2. That is second weight uh, from second input plus bias into 1. And what value you get if you substitute the values which are available on this network? Look at here, you have these values available. Here you have the values. You have I1, I2, H1, H2, everything is there in the network. When you substitute the values, you get this as the um, value of from output of H1. What is H1? Hidden one. This is summation, because every node has two operations. Every node will have two operations. First one is summation, second one is activation. So for H1, this summation is obtained through this process. How do you obtain summation? I1 through n, wi xi plus w naught, or b1. Okay, this summation is obtained. Then we have an activation function. I told you activation function, what it will do. Different activation functions we looked at: step, sigmoid, tanh, uh, relu. These are different activation functions. Based on the activation function, here sigmoid is used. For this example, sigmoid activation function is used. For sigmoid activation function, this is the equation: 1 over 1 plus e to the power of minus x, where x is this summation. Whatever value you get, here you can put any variable. You can put a, z, any name. Um, okay, let us not put x. Let us put z. Okay, let us put z, because x are our input. So this is the equation for sigmoid. And sigmoid activation function is S-shaped curve, and it yields the value between 0 and 1. It can be any value between 0 and 1 based on this set. We got this, and then we have this is known as squash. Squash of what? Squash of summation output. based on the sigmoid activation. So this also known as logistic function. Sigmoid activation is also known as logistic function. So 1 over 1 plus e exponent power net hi. Net hi is this value. So it is 1 over 1 plus e power minus 0.3775. Okay, and we get this output. If you uh, compute the values, you get this. And then you have to perform the same process for H2. Let us go back to this network and try to understand here again what we are doing. We are now calculating or computing the value for in the forward pass. In the forward pass we are going. So we have I1, I2, H1, H2, O1, O2. Okay, what is H1? H1 is nothing but you have H1. H1 is equal to this W1 into I1 plus W2 into I2 plus this B1. All right. This is H1. In H1 you have two operations. Summation you performed and a logistic function you applied to squash the output of summation. All right. Then what are we doing is we are doing the same process for H2 also, and we obtain this value. And same process, we are moving in forward direction. Remember, O1, O1, from where O1 will get the data? O1 will get from H1 and H2. O2 will get from H1 and H2. So we are computing for O1 in a similar manner. First the summation and then the sigmoid logistic function activation. The entire process has been done. What process has been done? You have taken the model from I1, I2 to H1, H2, and uh, finally to O1, O2. After you obtain the result, you have to find out what is the error. So output is the value that the model has generated. Target is our actual value. Like if we say 10 and this is 8, actually is 10, output is 8, like that. And what you have to do, this is a equation to find the total error. You have to sum. Sum means from O1 and O2, both you have to sum. And target minus output, and you do whole square to obtain the total error. All right. Then we get error of even, not even, O1. Error at O1 is this value. If you substitute the values in that equation, we get this. And O2 error is this. And the total error is this is the total error of O1 plus O2. You have obtained the error after the first epoch. All right. What is an epoch? Epoch is the uh, training of all the samples in the data set. Furthermore, backward pass begins. In the backward pass, backpropagation algorithm operates and update the weights such that this error rate is reduced. So here consider W5. What is W5? Look at here, students. Please remember, try to remember this. This is W5. This is W6. O1 is getting W5 from H1, that root, from H1 root, and W6 from H2, and O2 gets W7 from H1 and W8 from H2. Now, what you have to do here comes the chain rule of calculus. If you recall, you might have studied the differentiation and partial derivatives and partial derivatives. So what you have to do here, you have to find the partial derivatives. Partial derivatives of O1 means you write del O1 with respect to W5 into, this is known as chain rule, del W5 with respect to, from where you are getting W5, H1. H1 is getting from W1 and W2. So this is with respect to W1, value will be equal to W2. Is any doubts? Anyone is having any doubt? So this is, I am now computing partial derivatives. Partial derivatives means uh, in order to know how this W5 is impacting O1, you have to do this process. Means you have the value of O1. What is the impact of W5 on O1? To know that, further we have to find out what is the impact of W1 and W2 on H1. Because this W5 is coming from H1. So W1 W, and W2 both has impact on W5, and O1 has impact on W5, from W5, from W6, which in turn have from W1, W2, W3, W4. So this all, they are chained. That's why it is known as chain rule. They all are in chain. You know, if you put stones like this, when we were kids, we used to do like this. We used to put a smaller stone on a larger stone and so on. If you remove this stone, what happens? These above two will also fall down. You have to hold them while removing this. So what does it mean? It means that this stone has impact on these two stones, and this stone has impact on these three stones. One is built on another. You understand? So what is happening here? To know the influence of W5 on O1, we have to know influence of W1 and W2 on W5. This is only um, about finding the derivatives here. This is the plot. here this is the slope. At this point you find the derivative, at this point you find the derivative, and this point you find the derivative. You go on finding the derivatives and computing the weights such that you reach the goal. Goal is to reach this bottommost place. Here you will get the lowest error. Here you will have the lowest error. Here this denotes the error value. And we have weights. Here, all our weights are there. And weight new. You compute new weight from old weight by adding or removing a learning rate, eta, and by taking the derivative of loss with respect to the, the with respect to the weights, all the old weights. With respect to all the old weights, loss is computed, and learning rate means how at which point you take derivative. Like this process continues. This is only the back propagation. Okay, students, I hope you all are understanding. Okay, so now, okay, this delta rule, delta del e total. E total is the total error over uh, e total is affected by how did you get e total? You got e total from EO1, EO2. From these two errors, you obtained total error. So, in order to find the derivative of total error, you have to find the derivative of um, O1, and you have to find the derivative of O2 as well. So, here derivative of O1, okay. Now, derivative, when we say derivative of O1, from where O1 has received from H1, right? If you remember, from H1 that they have given the name as net O1. Net means that is coming in, and O is out is going out, net is getting in. So this input, whatever input this O1 is receiving, that contributes to the value of this output. So that is this one. And then further, what happens is this can be written as this can be written as del e total over um, del net O1. Net O1 means what? Mm, this one is dependent on this value and this value, like this. Okay. So del E total over del W5 is equals to del O1 out O1 into out H1. This one has this one, and this one has this one. And this process continues. Let us look at how it is doing. W5 computing new set of value, plus means new, is equals to W5. This is old. Okay, if there is nothing given here, it is students please try to remember that notations might differ with the different text and articles and blogs, but the essence and the gist of everything remains same. Some people will use this alpha, someone will use beta. It depends. So minus, this is eta, learning rate. Del e total means this is the total loss over del w5 with respect to weight w5. So this will be equal to zero point 0.4 minus, this is zero point 0.4, weight w5 weight value is zero point 0.4 minus, if we choose eta to be equal to zero point 0.5, then point into zero point 0.5, and what is this? This is the error. That error, if you multiply, you get some value, and this value is new w5. What was old w5? It was 0.4. But due to this error, this weight got updated to 0.35. Earlier, it was 0.4, and because 0.4 there was larger error rate, so you are reducing the weight value through backpropagation to 0.35. This process, you know, is performed on every weight, W6, W7, W8. You have obtained new Ws. And then look at here. Error on O1 node has been backpropagated and has been found the updated weights through this direction until W1. So this O1 through this way it has reached W1, O2 also through this way reached W1, because they all are connected with each other. Because amongst each other they all are connected. Apparently, um, every weight will have an impact on every other weight. So total is out H1, out H1, out H1, net H1 means this is influenced by this. This one, comes to this point comes to this point, and this point comes to this point. And O1 to out H1, then net H1, then W. So this calculation has to be done for every weight on every path. Uh, I hope that it is clear. So all of you have to, those who are in the class, all of you please try to work out. The notes have been posted in the classroom. Download the notes and work out on that. It is very important. And also, uh, if you don't understand, so that we can discuss again tomorrow. That is all about back propagation. Next, I would like to show you some practical stuff, because theoretically we are going, and it is becoming too abstract. To make things concrete, Let me give you practical example of how training of a deep learning model happens and how deep learning model classify an image into different classes. Students, it is very convenient these days to do programs without installation of any software, um, any uh, specialized hardware, because of the prevalence of cloud. You have cloud, and cloud provides you services like compute service, storage service. You can make use of it and you can execute complex and high-end programs on cloud. One such cloud is um, Collaboratory. Google Collaboratory. So type collab.research.google.com. Type this URL and hit enter. This is these are all of the recent programs which I have done. It has been integrated with Google Drive. So these programs are stored in my Google Drive. Presently, I am in my Gmail account, and this has also been, um, associated with GitHub. GitHub is a platform where you can store your programs. Your entire folders that contain several programs, projects, applications, softwares, all for that matter you can store in your GitHub. So GitHub, um from GitHub also I can open, and I have a GitHub account. Look at here, GitHub account where I post my um, programs. I store my programs, and I have my own applications, and some of the repositories I have taken from others. So a component or a unit of storage in GitHub is known as a repository. You will have repositories. Um, my repository. These are my repositories. This is my account. You all can create your accounts on GitHub. This is a cloud service where you can uh, post any kind of material, and this can be linked to uh, Google Colab, and I can open the programs from GitHub in Google Colab and execute the programs, and then I can upload from my local machine. um, I have several programs in my local mesh system, so I can upload the program into Colab and execute on cloud environment. I can execute in my system as well. However, it is convenient. Anywhere I can execute any uh, program on any machine, on any device. So I have some programs, Python. Okay, basic Python program I will open. I'm uploading this to my Colab. If I open drive.google.com, I can see there is a folder with the name collab. In that, I can find all my programs. Google Collaboratory has been built on top of Jupyter Notebook. Jupyter Notebook is an IDE, a platform which integrates coding, visualizations, commenting, audio, video, anything for that matter. And okay, this is a basic Python program which I have created. And in this environment, you find the program split into units called cells. This is one cell. And in Colab and Jupyter, you have two kinds of cells, code cell and text cell or markdown cell. Markdown cell is like comment. In Java and C++, you have like these comments, two slash, and you write anything. This is a comment like that. You have comment, uh, cells are two types, code cell and comment cell, or also known as text cell, or also known as markdown cell. Here, this is a markdown cell. This is a code cell. If you choose the code cell, if you select the code cell, this also part of text cell. This everything is in text cell. This also text cell, markdown cell. Here, this one is the code cell. When you select the code cell, you will find the play icon to the left most of the cell. This, when you hit this play icon, this cell gets executed. All right. There are other ways to execute this cell. Oh, variable name is equal to val. Val is not defined. Like this, you may get exceptions as well. So here, this is a cell that is initializing number 1, number 2 equal to 10. This is a Python program. And number 1 equal to 10. I have executed. Number 2 is also 10. I have executed. Then here, initialization is done separately. Two different values. Number 1 equal to 2, number 2 equal to 3. To execute this, you can hit shift enter, or you can hit control enter, or you can hit alt enter. There are differences. What I suggest is today you try to execute by using play icon, alt enter, shift enter, control enter, and tell me the differences tomorrow. Okay, so like this you can execute program. These are basic hmm, code cells. Machine learning program would be quite complex. Let me show you one machine learning program or deep learning program as well. Uh, right now, Google Drive is not able to get loaded. Okay, another way is to open from here directly. File, open notebook. Okay, file, open notebook. I can open from the recent notebooks. Python program extension is .py, and when you write Python program on Jupyter Notebook or Google Collaboratory, the extension would be IPYNB, which means IPython Notebook. IPYNB is the extension. So let me open this dogs cat classification. This is a deep learning model to classify the images into dogs and cats in these two categories. So what I can do is I can execute and show you. I would explain also later. Here, this is the data set. The data set has been downloaded. Okay, data set is being downloaded. After the data set is downloaded, here uh, the contents are extracted. The data set is in zip form, so you have to unzip it. Oh, there is an error because OS has to be imported. Without executing that cell, I executed this cell, and so I got the error. Uh, Code I would explain to you, but try to get the feel of deep learning model. What I'm doing is I'm just executing these cells, code cells. Here, these are the images: cat 820.jpg, dog 10.jpg, dog 100.jpg. Like this, these are the images. Then we are printing how many images are there. Cat, there are 1,000 images. Dog also, there are 1,000. This is training set. In training set you have 2,000 images, 1,000 cat and 1,000 dog. Validation, there are 500 images of cat and dog. And then you have to execute. Okay, this is executed. This is executed. Here, what are we doing is we are displaying a batch of 8 cats and 8 dog pictures. Here, this just visualizing. Here we are visualizing. Look at here. Here, 8 dogs and 8 cat images we are visualizing. And then we are building a small convolutional neural network model, and it achieves 72% accuracy. Means 72% of the time it can correctly classify whether the image is a cat image or a dog image. And this TensorFlow you have to learn, and Keras you have to learn in lab for lab work. And convolutional neural network would come in second unit, unit 2, I suppose. I would be completing unit 1 in 1 or 2 classes, and then we would be starting. Here, look at here. I told you about activation function. Here we are using sigmoid activation function. Uh, I guess we are using ReLU activation. Here, you have to specify activation function, the ReLU activation function. And then sigmoid, oh, here sigmoid is used at the output layer. So this is the model summary. We have created one model, and now we are going to train the model. Training the model is um, it is fit. Fitting is nothing but training. During training, oh, look at this, how slow it is. So what you have to do, if you find it very slow, you can change your runtime environment to runtime to GPU. Oh, right now it is GPU only. Even then it is slow. You can go for TPU, tensor processing unit. None means normal processor, GPU means graphic processor, TPU means tensor processor. The tensor processor is the fastest. Graphic processor is also very fast. Look at here, epoch. One epoch means all the iterations of all the data samples of the data set. We have how many data um, samples in our data set? We have 1000 cats, 1000 dogs. In training set means 2000. Our data set is divided into three parts: training, validation, testing. So if I give you an analogy, training is like taking classes for you all, and validation means conducting internal exams. Testing is conducting external exams. After conducting internal exams, you get to know um, what you are good at, and even teacher gets to know what concepts are difficult for students. So that is validation of the model. Training means you just start from the scratch and go on explaining. So this is what is happening here. Here we are training the model, and we are this is with respect to training data, and this is with respect to validation data. So there are 15 epochs. There are 15 epochs. So one epoch means all 2000 samples um, will be moved forward and backward in a forward pass and back pass. Just we studied forward pass and then backward pass. So every data sample is given to the network, and then it moves from input to output, and also it gets back from output to input. And then uh, how many such iterations you would like to have, that depends on the batch size. So you can do it individually for every sample. That is known as uh, batch gradient descent. You can go for mini batch, means instead of um, all 2000 at once, what you do 50-50 or 60-60 samples in a batch. Okay. um, Here this is accuracy 54%, loss is 8% in the first epoch, and this process continues till 15th epoch. I will explain you all the things, don't worry. Again, I am just showcasing you to get the feel of all this, so that you get an idea. Okay, finally you got a 98% accuracy on training data and 71% accuracy on validation data. Means all classes are happening properly, but in internal students are not scoring well. Okay, that is the meaning. And then this is what is learned, means this is known as feature map. Look at this is the graph. We are plotting the graph of training and validation accuracy, and graph does not seem good, it is showing overfitting. What is overfitting? I will explain you. Okay, students, this is all about today's class. From tomorrow, the classes are not static, they are dynamic. We have got duties, invigilation duties. As and when I am free, I will post the message. You all have to make yourself available uh, whenever you get a message. Otherwise, I will post a 5 minutes before so that you all can join. I'll be posting the links in the group. Then you join. Okay, students, any doubts? So, ah, okay then. I'm signing out for today. Oh yeah, yeah. We know that I will send GitHub link. I'll send my GitHub link. Okay, students. Bye bye.